So exponential functions are one-to-one. What does that mean? Well, let me show you some functions that aren't one-to-one, and then maybe that will help elucidate what we're talking about here. So let's look at our first example will be f of x equals x squared. If I take a value on the y-axis, say the number 4, I can ask what values of x correspond to that value of y. In other words, what are the solutions to f of x equals 4? Or what numbers when squared give me 4? Well, there's two numbers that when squared gives me 4. There's x equals -2, and there's x equals +2. I can get those numbers by going over to the graph and going down to the x-axis. Here's 2. Here's -2. There are two numbers corresponding to this one number. And so that means it's not 1-to-1, it's 2-to-1. So this is a 2-to-1 function. Well, it's not, I wouldn't say it's 2-to-1 everywhere. There are some numbers like 0 that have only one number corresponding to them. But it's not a 1-to-1 function because there are some numbers like 2 and -2, they both get sent to the same place by the function f. So f takes 2 here and -2 there. So it's not 1-to-1. Another function that's not 1-to-1 would be, I was going to do something different, but let's try this one. Let's try Sine X. In fact, this function is infinite to 1, right? If I take a value here, I'll take the number 1. There's lots of values that correspond to 1. All these values here, 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 and it goes on. This function oscillates infinitely often, forever, and so I have infinitely many values that get sent to 1. What are these numbers? Well, this is pi over 2, 5 pi over 2. This one, let's see, it's minus pi over 2, minus pi, minus 3 pi over 2. There's lots of them. So all these numbers, and there are more, right? They all get sent to 1. So it's not a 1-to-1 function, it's infinite to 1. Well, exponential functions are 1-to-1. If I look at, so done with the not 1-to-1 functions, let's look at our exponential function. It's either going to look like this, if b is greater than 1, or it's going to look like this, if b is less than 1. Right, we know that. But look at what happens. If I take any number here on the y-axis, there's only one number corresponding to it on the x-axis in either picture. And that makes it a 1-to-1 function. Because of that, that means that we have this nice property. If b to the x equals b to the y, so if the outputs are the same, then the inputs must have been the same. X must have equaled y. That's a property that 1-to-1 functions have, that these other functions that we looked at don't have this property. Just because the two function values are the same doesn't mean they came from the same place. In fact, this one up here, the sign came from many different places to equal 1. But here, if the two outputs are the same, the inputs must have also been the same. And so this will allow us to solve equations that look like this. We can solve an equation that looks like this by using this property and writing down a simpler equation. Okay, so let's take a look at some examples where we use this property. The book calls this the 1-to-1 property. So let's take a look at some examples where we have to solve equations using the 1-to-1 property. So we have two, this is an exponential function with x minus 3 plugged in place of x. This is an exponential function with 1 plugged in place of x. In other words, what I can do is I can write this as this. Now, what did the 1-to-1 property say? The 1-to-1 property said that if b to the x equals b to the y, then x equals y. So if 7 to the x minus 3 equals 7 to the 1, that implies that x minus 3 must equal 1. And so we can solve this for x. Right? We just add 3 to both sides. X equals 4. And so we got our answer by using the one-to-one property. It essentially allows you to strip off the exponents and just treat them separately. Let's look at another one. All right, this one isn't as obvious because here the bases were the same. I had a 7 here and a 7 here. Here they're different, but I can view them as the same because I can write 81 as a power of 3. 81 is actually 3 to the 4th power. So let's write it like that. Oh, see, now that I have the same base, the bases are the same, I know that from the one-to-one property of exponential functions, I know that 3x minus 2 must equal 4. And that's just the one-to-one property. And now I can solve this by adding 2 to both sides, dividing both sides by 3, and my answer is x equals 2. Right? And you can plug these numbers in and check, right? If I take 2 and plug it in, I get 3 times 2 is 6, minus 2 is 4. 3 to the 4th equals 81. I'm going to check this one too. Plug 4 in here for x. 4 minus 3 is 1. 7 to the 1 equals 7. It checks out. It never hurts to check your answer. Okay, let's look at another one. What can we do here? Well, we need to get it in that form that we can use the one-to-one property. So I need to have a single e to the something over here. Well, I can do that because I know properties of exponents tell me that when I divide, I subtract the exponents. So the first thing I'll do is use that. This is the same as e to the x squared minus x. And what can I do next? Well, now I can use the one-to-one property because if these two things are equal, the exponents must have been equal. So x squared minus x must equal 6. How do I solve this? Well, we've talked about lots of methods for solving this. Completing the square works. Situate this so you could use the quadratic formula, but I think factoring is the easiest way to go. Just subtract 6 from both sides. Factor the left-hand side. And our two solutions just pop right out, right? The thing that makes this 0 is x equals 3. The thing that makes this 0 is x equals negative 2. So there are two solutions here. And you can check them out. If I plug 3 in here, I got e to the 9, right? Because 3 squared is 9, divided by e to the 3. When I divide, I subtract the exponents. 9 minus 3 is 6. So that works. And what about the negative 2? Well, negative 2 squared is 4. So I have e to the 4 divided by e to the negative 2. So I have 4 minus negative 2. 4 minus negative 2 is 6. So again, it checks out. So both of these do indeed work. There's no 5 on the right-hand side. So what do we do here? Well, you can still do it, right? Because you can write 1 with the base 5, right? 1 is 5 to the 0 power. So the one-to-one property says that x must be equal to 0. So very quick there.